Hello and welcome, ladies and gentlemen. As you can see, we're not really in the fancy setup today, just my regular office. This is what the background looks like if I don't have the lights and stuff on. You can see why I keep them off. It's kind of boring. Anyway, today I put together an application to try to help explain hypothesis testing a little better. And I really wanted to walk through this with y'all. This is a completely supplementary video. You're not going to be tested or anything on this, but I'm really hoping it helps to explain the intuition behind what's going on. So what I'm going to do, I'm going to pull this up. I'm going to explain it. And I'm going to explain it using very not technical words, and then we can connect this back to technical concepts. To hopefully just, again, help you build intuition as to what the heck we're trying to do here. So let's jump in. So for this application, I'll actually make a link to it available so that you can go play around with it as you want. But essentially, this is what we're trying to do largely with hypothesis testing. We essentially have a cloud of data, and we're trying to see if the red dot is part of the cloud. And that's it. That's the end, period. No other things involved here. So we've got the red dot, which represents our data or the test statistic. The cloud, this represents our sampling distribution, or the Z tables or T tables. This is different data points taken from a Z table, essentially. Randomly generated from a Z distribution, but that's the idea here. Is we're trying to see, is this red dot part of the cloud, or is it something different? And if it's something different, we call it statistically significantly different. We reject the null hypothesis. If it's part of the cloud, we fail to reject the null hypothesis. We say there's not evidence to make it further from to determine it's different than the cloud. And again, we call that fail to reject the null hypothesis. So that's the idea behind hypothesis testing. All we're doing is trying to see, is the dot part of the cloud or not? And yeah, that's kind of it. Now, there's a couple things that play a role into this type of decision and conversation. For instance, two things can play a direct role. One is the location of the red dot. So for instance, the red dot could be at a different place. And depending on where the red dot is, well, now it looks much more like it's just a part of the cloud and not something different. Whereas if it's somewhere a little bit further out, it looks very different. And doesn't at all look like it's part of the cloud. So the distance, in a sense, from the red dot to the center is a big component in making this decision. Is the red dot part of the cloud or not? Similarly, the spread of the cloud, or the standard error of the data, or standard deviation, if we're talking about a single data point, is a huge piece. So if I increase this to be much bigger, well, now this red dot, which looked far away from the cloud, now looks like it's just a part of the cloud when that standard deviation is increased. When that standard deviation is dropped down to be even really low, man, this red dot looks extremely distinct for data that aren't as spread out. So we have a measure of distance, how far away is the dot from the center of the cloud, and we have how diffuse is that cloud. And again, the terms we use are standard deviation when talking about a single data point, or standard error if we're talking about group means. A last thing that can come up is, well, the cloud's kind of, let's kind of put it kind of at an edge. Like, looks like there's a couple of pieces of the wisps of the cloud, in a sense, that go beyond it, but it's kind of at the edge. Like, where do we do a cutoff? Reasonable people could disagree in another way. Like here, maybe, like, is this part of the cloud? Well, I don't know. I'd say probably kind of. You might say, no, it's kind of on the edge. It's pretty unlikely that's part of this cloud. And so how do we come up with that conclusion? Well, this is where our Z tables, all that probability that we've talked about in class, comes in. So when we talk about this, what we usually do is we decide based on what percentage of the cloud is outside. And then if this is further away than a certain percentage of the cloud, we might say, well, that's enough in these edge cases to help decide. Again, we're not really talking about it here. Like, everybody agrees the red dot's not part of the cloud in this case. We're more talking about, like, all right, what if it's an edge case? How do we make this decision? Visually, what this looks like is confidence, a critical value. And so if I show a critical value on a circle here, this is what that critical value looks like. Note that if the spread of that null hypothesis distribution, if the spread of the cloud increases, well, now 95% of the data being inside this, 5% being outside, looks different because the spread increases. So it really depends, this circle depends on how spread out the data is, but gives me a place where I can kind of say, oh, the red dot is inside of the red dotted lines. Okay, that's part of the cloud. The red dot's outside of the dotted lines. That's away from the cloud. Note that another thing that can influence kind of these edge cases is kind of how clear you want this to be. So like for me, if it's right here, well, it's in the middle of a whole bunch of dots here. Maybe I don't think so, but you do. So a 95% confidence interval says, yeah, it's outside of 95% of the data. But for me, in my mind, I'm thinking, oh no, it's got to be outside of 99%. It's got to be outside of most of the data for this to count. So for me, maybe that's not it. And this is where that confidence range comes in. It changes this width of the circle in terms of defining what is part of the cloud and what is not part of the cloud. Again, going back to it, the red dot is meant to describe, is this part of the cloud or not? Falling to our technical terms, this red dot is our test statistic. So when we write out a test statistic, this is shown in 2 dimensions, not 1, but when we write this out, this is our test statistic, the distance from and we take, this is our observed sample statistic. And then we take the distance from this to the null hypothesis. That's the center of the cloud, is the null hypothesis. The cloud itself, this is an empirical distribution, which means I took a lot of data points rather than doing the curve. But this is the normal distribution, or the t distribution. The sampling distribution, or what we assume the data are distributed as under the null hypothesis. So again, we're trying to essentially see, is our value distributed under the the null hypothesis distribution? Is our test statistic under that null hypothesis distribution or not? And then, of course, our circle here that we're kind of using to identify edge cases and help us navigate case. Again, nobody's really debating when our dot's super far away. The question is, when it's in this edge case scenario, how do we know, is that enough or is that not enough? Again, in this one we were talking about earlier, this really seems like it's kind of, surrounded by a lot of data points here, just based on this random graph I put together. And the answer can be fine. If you want it to be outside of kind of this threshold, maybe you're more of a 99% confidence interval person, not a 95% confidence interval person. You want to be more sure it's separate from the data cloud. Yeah, and so that's kind of the main thing that we're doing here. Maybe one last thing that I'll show you on this little app is I made a collapse into histogram. So this is a 2-dimensional representation of what we do. That is, we have like z-scores on the x and y axis. The truth is, though, in a lot of your textbooks and even in my lecture slides, we talk about this almost always in 1 dimension. So let's look at what that looks like. In 1 dimension, typically we have this curve. In my case, I'm doing a histogram. We have these cutoff bars, and then we have our test statistic drawing a line straight down in a particular place, indicating this is where our test statistic is. And we say if it's inside of these dotted lines, then it's not statistically significant. That's part of the data cloud, or in this case, part of the distribution. But if it's outside of the dotted lines, either on the front end or the back end, it's outside of the cloud or outside of the distribution, indicating that it's different than the rest of these things. Again, for me, for whatever reason, in 2 dimensions, this is a little easier to see. You can definitely be outside of the cloud over here. You can also be outside of the cloud over here. That's fine too. It doesn't really matter where you're at. You can be outside of the cloud in either direction. Doesn't particularly matter. And so again, you see this image a lot, but the main goal is, again, identifying or trying to determine, is this data point part of the cloud or is it its own thing? And that's what we're trying to figure out when we work through these types of problems. Now, where do we use this? Well, again, think about cases where we're trying to determine if something is performing abnormally good or bad. So we try a new method and we want to see, does this really blow our old methods out of the water? Or do we not really notice a difference between this and our old methods? And then vice versa. Is this working a lot worse than our old methods, or do we not really notice a difference? This happens all the time as we look at process improvement, as we look at trying to get better. We look at trying to improve what we do at companies, at organizations. This can be in terms of process. This can be in terms of work with customers. This can be in terms of product. This can be in terms of virtually anything that we interact with. I use this in education, trying to figure out what are the best ways to teach things. We can teach it in way 1 and way 2 and see, are the average test scores in one of the ways outside of the cloud of what we saw in the second way? And if so, then we can feel really confident that, okay, maybe this way is a better way to teach something. But again, that works just as well with marketing. That works just as well with customer interaction procedures. That works just as well with ROI on specific outreaches. That works just as well in terms of different process and procedural things in any company. How can I do this in a faster, better, more efficient way? And again, all of those things are things that people are looking for because ultimately they help us to bring more value to the places that we're working and the people that we're working with. Maybe one last thing that's kind of a fun thought experiment extension, if you will. If you think about that dot and you think about the cloud, we kind of talked about hypothesis testing, where the cloud is kind of centered on 0, 0, and the dot is out here, and you've got that little circle. If you think about a confidence interval, what a confidence interval does, for all intents and purposes, is moves the cloud to be centered on our dot. And that red circle moves that red circle to be centered on our dot. Now, what does that do? The cool thing that does is says, okay, well, if we think that everything is kind of distributed in this way, and we have a data point that says this is the center of or this is the data that we've observed, that red circle now provides a reasonable range that we would expect things to fall into. And so that's kind of a fun application of using this idea or this mental image that I made for hypothesis testing, but works well for confidence intervals too. If we take the circle and the width of the circle and we just center it around our red dot, that gives us a range that we would expect things based on our data. So what reasonable range would we expect the mean to fall in based on our data? Well, that's what that circle could tell us in that distribution of data points. In any case, supplementary video, little application. Let me quickly show you how to get access to this on your own. So if you go to, change over the screen here, and it's kind of hard to zoom in, but it's drflorin.github.io/HT-JS-VIS. That'll take you to a place where you can play around with this graphic yourself if you want to, and kind of explore and get a feel for all of the things that I showed you in the video today. I'll try to put a link to it on our Canvas page in case you want to explore it a little more, but definitely wanted to make that available to you if you're watching through this and if this was helpful. So anyway, hope this helped. Hope y'all have a great rest of your day, and thanks for sticking with me.